You see that icon just went dark up here, right? So that's the sign that I'm recording. Okay, cool. So let's get to this a little bit. So let's talk about Git. So Git is software that we use, okay? So it's an application that's, part of our tool set. And we primarily use Git for what's known as version control. Whoops. And sometimes my hand will hit the button and kick me out of the thing. And then I have to reinitialize the pencil. Version control, okay? As we know, software goes through versions, right? We probably all on our laptops or our phones or whatever see software versions update, right? And we go from version 3.1 to 3.2 point whatever, and that's a normal part of it. And Git is software that helps us manage versioning of our products that we build, okay? So part of what we have to do in this course is start learning how to use this software, right? And how to start learning this process of version control. But another important part of working with Git is that it's also a vehicle for collaboration. It allows multiple people, multiple teams to work on a single code base together and to have their own versions of that code base where they're developing different independent paths of progress on it that then can be brought back together. And it is super handy and super useful, and it's a really fantastic, amazing tool. But there's a bit of a learning curve in learning how it works. So the two components of this that we'll use, Git is software that runs on our laptops, okay? So that is an application. We're also going to be using a website called GitHub in conjunction with Git to collaborate and share and work on code together. Okay, so GitHub is the website that is a cloud-based central place where our work done being controlled in Git can be shared and collaborated. So that's sort of the overall of those two things. So if we think about like a software project, right? Let's just start something. I'm just going to build a little box here, and let's say we're going to build a software project that does two things. Okay, let's say that it's going to have an order form and let's say it's going to have a shopping cart. Okay. Right, and let's say that this is a website for a business, right? Some commercial entity that's selling something, right? And we need to build out functionality for the shopping cart and the order form. Well, it might well be that there are two separate teams that are going to build each one of those parts of this project on a timeline. And they're going to have different points where they're going to sort of mark their progress as things go through, okay? This is what we think of as sort of the basics of version control, right? As we build something out, we add a new feature, we flip it to a new version, okay? But what's possible with Git, that's kind of the mind-bending part of it, is that we can actually, in a single project, have multiple simultaneous timelines of development on that project. And Git is super smart about knowing what parts are different on each of those alternate timelines, and then allows us to bring everything back together. Okay, so conceptually, that's what's going on with Git and with version control. There's a really good diagram that I like to show for this. Let me go find it really fast. Go to the internets and go to, say, Git workflow, and it usually pops up in the very first page of hits on here. And that's what I'm looking for right there. Okay. All right, so let's talk about a typical software project and look at a diagram of it. Oh, Lord, that's not what I wanted. Let me just pop this open in a new tab. Okay. And there we are. Okay, cool. Not that much. There we go. So let's see what's going on. Okay. So if we think about a piece of software, a software product, there are a lot of different versions of it that exist. Okay. At any given moment, with multiple teams working on it. This is actually not the diagram I want now as I look at it a little more clearly. Let me go back. It looks a lot like it. The one I wanted is this one. Yes, that's the one I want. Okay. Okay, cool. Okay, so let's talk about those different parts of it. Right, so we'll have our master, and this is a term we'll use in Git, what we call our master branch, is our primary release branch. This is the one that is publicly available. This is when somebody goes and downloads the latest version of our software. It is the version that lives in what's referred to as master. So this is our public-facing, published production work. However, there are also a lot of alternate versions of this software that can exist as different teams are working on different components and different pieces of it. So for instance, we can think about there being a separate timeline on which we manage what are called hot fixes. Basically catching bugs that sneaked through and fixing those really quick. We could also have development branches and feature branches where we build out new features for software. This is where we would have like a branch for the order form and a branch for a shopping cart and maybe a branch for a receipt page after somebody's completed the purchase. Those things can all be developed on separate branches that are all birthed from some pre-existing version of the software. Okay? Eventually, we could take all of these different features and aggregate them into what's called a development branch. And then the development branch can go through testing and revision. And when that is done, as I make this a little smaller, you can sort of see this whole process. It eventually can be pushed back out and become a new published version. So we start with our basic version, and we create a duplicate of it into a development branch. That development branch may have a few things happen on it, but then we can spawn from this moment multiple feature branches that then kick back into our development branch. And eventually, the work in this development branch, and then we'll move into what's referred to as a release branch, where more bugs and things are worked out. And eventually, it gets to a point where it's done enough to push it back out and publish it, and we then version to a new number instead of 0.2 to 1.0 or whatever, okay? So Git is the software that we use to manage all of these multiple timelines of code. And for our purposes for this week, we're not even going to bother with working with branches until Friday, okay? Working with branches in Git brings in a lot of new complexity to software projects, and we're not going to get there until Friday. I want to get you comfortable with the basic sort of operational pieces of working with Git before we move into that next layer of complexity of multiple timelines. Because, you know, it's like science fiction almost. You know, people shift between timelines, and it's like in an alternate universe, this happened, right? And Git is sort of our way of having alternate universes for a code project, okay? So there's some things just to know about working with Git that are just kind of some mechanical pieces. All of our interactions with Git, we will be doing in our Unix terminal, right? So we'll go over some Unix commands later and things we can do in here. But this is where we're going to interface with Git, is through commands in the command line. One thing that you'll be working a lot more with in the coming weeks is using the command line to manage your work and manage your code and organize your file systems. It seems in a way, kind of like, really? It's easier just to like click and drag things with a mouse. And in a way it is, but it's also really kind of clunky and tedious and slow to do things with a graphic user interface, or what we call a GUI. Using a text-based command line interface is so much faster and more efficient for a lot of the type of work we do. Plus, it's the best way to work with Git and see what's going on in your code projects as we evolve them forward. So we're going to talk about that more in the future. But as we go through and sort of talk about the processes of the things we're going to be doing with Git, where was I going? I was going there. There's one process that you're going to do a lot, and I just want you to get familiar with it and kind of know the pieces of it right away. And this is what we refer to in these parts as the ACP process. In other words, add, commit, dang it, push. Yeah, I did push. I pushed the little button on the iPad, okay? And the add, commit, push process is basically how we prepare something to be saved, a commit is where we actually save it, and then push is where we send the saved version to GitHub. Which in a lot of cases I will just abbreviate to GH, just to kind of be quick. But this is a process we're going to use a lot. When you're working with Git and you're working on code projects, you'll be working on a lot of different files and in a single project, right? Every project is made up of many, many, many multiple files. The ones we build in 201 are typically going to have 3 to 6 files in them. But when you get to 301, by the end, you're working in a code project that's composed of about 40 different files, right? So there's a lot of stuff to manage with those different pieces of information. And so when we talk about adding something in Git, preparing it to be saved, what that really means is that we are indicating which files we want to save a version of at the moment that we're working on them. Okay, and there are times where we don't necessarily want to add everything into a project that is going to be saved. For instance, what if we have some sort of secret sauce that we don't want to push that's public in our software? What if we have like a password or a token or an authentication key that maybe we don't want to push that somewhere that is publicly available? We don't want to share that. So we don't always want to save everything related to a project. Sometimes we only want to save pieces of it at a given moment to share in a particular way. And this complexity will make more sense to you as we build out more. The actual process of saving a moment in time is what's referred to as a commit. Okay? And so when you see these timelines, sort of like I had here for the 2 branches, one for the order form and one for the shopping cart, you'll oftentimes see a dot on a timeline be a representation of what's called a commit. Okay, and the commit is when you actually capture that moment in time. Hey, this thing is working now, save it before you go try to add a new feature to it and break it again. Right? You're always going to be breaking things and fixing things in code. And so you can think of a commit as kind of being very similar to a save as command in like a word processor or something, where you are saving a moment in time of that project and you have a moment that you can then roll back to. But it is its own independent existing entity. And so what's really cool about Git is that, think about like if you were writing a paper for a class, say you have a doc called term paper .doc, And then you're building on it, and it's like, oh, I need to add a bibliography, right? So then I'm going to say, do a save as, and do term paper bib.doc. And then as I build it out farther, I realize I need to put a cover page, and so that I save as and do another version that has a cover page. Right? Have you ever experienced that world where you just save as and you get all of these multiple copies of the same thing, and all of the saved as versions are just different moments in time of it? Git does that under the hood for you. Every time you do an add and a commit, Git creates a marker in its record keeping system of what the state of the code was at that time, and provides you a way to roll back to that point if in the process of trying to build something new, you just broke it all to hell, right? And it's like, well, this is all broken. I can't work with this. I need to roll back to a point where everything was working and start trying to build this out again. Git is what gives you that capability of time travel back to previous moments in time to help you sort of conceptualize this process, okay? So the mechanical parts of working with Git are the add and commit push pieces, and we're going to see these tomorrow. We're not going to actually do any hands-on Git today. Tomorrow's we have first day to do hands-on Git. But hitting this conceptually, I think, is just really important as sort of a process to see how this all works. So another thing I'll show you just as kind of a reference to this as well. I'm going to pull up a GitHub for a student project from a little ways back. So we're going to go to the this code project by some students of mine a couple of years ago. But I like to come back to this reference because it's just a really good one as an example of good Git flow. So this is a code project called Hour Long Lunch, and this is basically an application that found nearby restaurants and lets you know where they were. In particular, this one was really good with food trucks and finding food truck data and presenting that data in the web so that on different days, if there's a lot of food trucks around, you know, the same stuff's not available at the same place different days, right? They move around. Anyways, that's what this did. And we can just look at the setup of this project. You can already see that this is in GitHub, right? There's already a bunch of files that are involved in this project at this point. And if we go in here into this public directory, here we'll see our different HTML files, and then we'll see our JavaScript files in here, and our image files in here, and our CSS files in here. And so this is how this project was tracked using GitHub, and this is publicly available, right? All of our stuff on GitHub is publicly available unless we get a subscription to have private repositories. But it's all publicly available. But that's how this team collaborated on this. And so what I wanted to show you on here, just to kind of give you a little more framework on it, is if we go to this Insights page, and we go to the graphs, this will show us some life cycle of this project, okay? So here we can see who the contributors were on this project, right? So this project had 4 people working on it, Benton and Bella, and then Kelsey and Stephen over here were working on it. Do any TAs, any of y'all know Bella? Yeah, you know her. Yeah, she's probably going to come back and do a lunch and learn sometime soon. Yeah. So this is back when Bella was a student in the precursor to 201. So a couple of years ago. Anyway, she's a front-end developer now for a company. I forget the name of it. They do a lot of auto dealership websites. And yeah, she went from being a hairdresser, which is what her previous career was, to now she's a software developer. Pretty cool. Anyways, we can look in here and see who contributed to this project. And there's data about when the contributions were made and what type of contributions and so on. But what's really cool to see, though, is this network tab when it comes to trying to conceptualize how Git works. So what I'm going to do is I'm going to slide all the way over in time back to the beginning of this project. And kind of, we can look at the life cycle of this project by looking at this diagram. Okay? And again, we're just trying to conceptualize how Git works and how we manage version control. Okay, so here is the master timeline in black here, okay? And so each of these black dots on that timeline represent a commit, represent a save as moment, represent a moment in time. And so what happens is that from that main timeline, we will branch off into an alternate timeline, and we can do our work and have intermediate versions of our work being built. And once we get to a point that it's ready to re-push or re-add back to the master timeline, then we can do that, right? And so you can see with this project, like on the first day there, just doing some basic build out on things here. And then this is a little weird in here. Let's look at this section though. This is a good one. This part here, you can see where they broke off and actually did 4 separate timelines of work, right? So probably each one of the 4 members of the team was taking on building out of a different feature. And as they got that built out, they would then merge it, as we call, back into the master branch. So this yellow one was the first one to merge in. While it was being merged in, there was still ongoing work on the purple, green, and blue branches. Eventually, the green branch got ready to have its code merged in. And so it did there. Perk was still going on the purple and blue branches. But then the purple branch got to be ready, and it was merged in there. And so as we see this process kind of play out, as we're moving in time left to right, we can see how the publicly facing version of this was incrementing at a sort of slower pace than all of the work going on under the hood. And that work going on under the hood could be merged back into the master branch, and Git tracks all of this stuff for you automatically, okay? It's a big conceptual thing to sort of understand how Git works, but you know, once you have it, it's a really powerful tool, really powerful tool. But it just has to do with versioning and timelines and how we take a problem and we work on it, right? Which actually leads me to sort of another big concept here, and this will be the last thing we do before we break for lunch, which is sort of our process for problem solving in code, right? So the way I like to talk about this is back when I did my PhD in music, I also did a minor in electrical engineering. And my mentor in engineering is an old Florida guy named Mike Lynch. And Mike's a big old funny guy, and he's very kind of, I don't want to say he's backwoods exactly, but when you first meet him, he comes off as just kind of being a good old boy, sort, you know. And anyways, Mike had a great way of describing how problems work. He'd said, you know, I'm not smart enough to solve big problems. He said, I just don't have the ability. I'm not that smart. He said, but what I can do is take a big problem and split it into a bunch of smaller problems that I can solve. And that is basically what's going on when we write code projects and how we solve problems, is take big problems and decompose it into little ones. And maybe we need to take these smaller problems that we decomposed out of the big one, and maybe those are still too big, and maybe we need to take each of those and make those into smaller problems themselves, right? And ultimately, that's how we solve code problems, right? If I want to make a website that sells cars, then I need to have a lot of different pieces that go into that, right? I need to have something where people can look at cars. I need to have something where people can see prices. I need to have a way for people to put in information. I need people to find out where things are, right? And all of a sudden you start thinking about it, and there's a lot of little stages to the process. And problem solving is like that. Where we take a big problem, we decompose it into a bunch of little ones. For instance, if I was to ask Teddy to go get me some coffee, right? I could just say, Teddy, go get me some coffee. I'm kidding. I don't want any coffee. And he knows how to do that, right? He would be capable of that. However, If he had never gotten coffee from me before, or if he didn't know, I would have to say, okay, David, first off, you need to stand up, and then you need to turn your body 90 degrees to the left, and you need to walk ahead 3 steps, and then you need to go walk through the door. So you have to push on the door until it's open enough for you to walk through it, and then you have to walk through the door, and then you need to angle your body 45 degrees to your right and walk straight ahead for 55 feet. At the end of 55 feet, you stop in front of the coffee maker, and yada, 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 right? It's a set of detailed instructions. That's really what code is, okay? And writing the instructions, our ability to do that is completely dependent upon our ability to take what we're trying to do and break it into smaller pieces. And then when you take what you're trying to do and you build it into smaller pieces, say you are a company trying to build a website for people to go buy cars, maybe you take those smaller pieces and you assign them to different people and different teams, and they work on them simultaneously, and that work will happen much faster on teams than it would if one person just built the whole thing themselves, right? So when you think about this conceptual, taking big problems and splitting it into a bunch of small problems, and you think about the idea of different teams working simultaneously on a large project that has features or components that have been split into smaller pieces, then the utility of a tool like Git and this timeline feature where we can have multiple things being built at the same time that eventually will come together into a master branch becomes more evident, right? So this is how we share code, right? We don't email code to one another. Used to, a long time ago. That was a horrible way to work. Or send documents around. Now we just have this central base that we can go into and pull the code that we want out of it, make the changes we want, reintegrate them back in, and it all works super smoothly and seamlessly. So last thing, since I have the TAs here, one thing I always like to do when the TAs are around is get their input on concepts. So TAs, I'll ask you, what's your best 30 seconds of advice on conceptualizing Git, knowing that each of you 6 to 18 months ago had no idea what this was? What would you say? Anybody? So Ron, what would you say maybe is the best quick explanation of how Git works and what you learned about it when you first started using it? That's really cool. That's why I asked. I'd never thought about that way. Yeah, Kaylee, what about you?
I think something that helped me a lot when I was first learning Git, I'm a very hard to really well. I think something that really helped me was once you actually start learning the concept of like add and Git stash and whatever, actually writing them down and just reading those so that you can refer back to them and be like, oh, okay, I need to create and
Hmm.
or stash this, then or whatever. Just having a great description of what it is against it to start to put it in understanding of actually the process. That was really helpful.
That's really cool, and I think that's a great piece of advice, which is when it comes to working with Git, which we will actually get hands-on with it tomorrow, um, by all means, make yourself a cheat sheet and use it. Don't try to remember everything. In software development, everybody looks up everything all the time, right? So don't think for a second it all has to be memorized, It doesn't. Make yourself a good handy reference or cheat sheet. So Kayla, what would you say?
With that cheat sheet, we use Google to problem whenever I find a link that, like, oh, this link helps me solve this kind of problem, and I'm going to need it 1,000 times. I'm going to save that link, and I'm going to save it in a section that is appropriate for that. So for like all my Git commands, I'll take notes on ACP and stuff like that. But what about stashing? How do I get stash back? How do I do these other things? It's on the internet, and I would just put that link with it. But it for me, it seems like a monster at first, especially when you're like talking about the collaboration part. You're on your collaboration.
Yeah, they pair on Thursday. That's first pair programming day.
Oh, okay then. Sooner than I thought. I forgot that was Thursday.
Yep.
But yeah, it's actually really not as hard as it seems. Or it, yeah, it starts making a whole lot of sense. You're gonna be using it every day, so don't freak out about not understanding it. It'll come to sense.
Yeah, it's a complex and powerful system, but with it comes the sort of the expense of learning it, the learning curve. Yeah, Teddy, what about you?
I'll tell you this much. There was a couple of state partners get we stayed until probably 11:30 because it crashed on us and broke it. And we had to have PAs and Sam actually help us out with it.
Yeah.
And I didn't take notes, so I will riff on what they all said. Take notes on Git because it is such a stupid complex thing to do. You need to continue to research it. I mean, there's a lot of things that my class did. Like we had there's a Git program out there that'll actually you can play a game and put in Git commands to learn with it.
Hmm.
Do things like that. It's just it's confusing at first until you actually really understand what's doing. That comes. Yeah.
Right.
Especially you're learning about to fix something.
Right. And as I said earlier, I think Git is probably the toughest thing we're going to face this week. And all I wanted to do today was just present the concept of it so that you have 24 hours or so for your brain to spin on it and chew on it before we actually work with it by hand. But again, just as I've said with code, where you're going to run into errors in your code and you're going to make typos and that type of stuff, you're going to have problems with Git. It's normal. It happens. And so there will be moments. There you have gituations, as we call them. And they will escalate at some point into total Git shows. All right, that's going to happen. So, but it's okay, that it happens because that's how we learn. Again, and when we struggle, it's when we're growing. Go ahead, Teddy.
I've got one more thing. Here's the problem with Git. Like with our problem, like we learned so much from that problem that like we're not scared to tackle Git.
Right.
It's super easy for us now, and it'll get easier.
Yeah. Did y'all come through? I know Ron was through before, but I'm not sure about the three of you. Before we did that merge conflict exercise, or did y'all do that at the end of 201? Because y'all were in Adam's first group, and Adam didn't use that exercise. Right. Yeah, I have an exercise on fixing merge conflicts. I call it the Bob, Carol, Ted, and Alice merge conflict. Yeah, I'm gonna rough Adam up. No, it was his first 201. He overlooked it. We talked about it. But anyways, I have an exercise that's for that. So anyways, just to kind of put a wrap on this, so we can get out of here and get some lunch going. Just let your brain fizzle on this a little bit. Just let it think and let it go. And tomorrow we're going to get hands-on with the Git part. All right. So looking ahead for the rest of the day, what we need to do is we're going to break for lunch. After we return, we're going to be in the classroom next door. Remember, this is that weird first day where usually this time of day we're breaking and we're in lab for the rest of the day, but we have an extra long lecture on the first day. We're going to be in the Babbage room, which is next door, and it's 12:07. We should just plan to resume at 1:15. In the meantime, we do need to clear all of our stuff out of here because there's a class that's going to start in here at 1. And we'll reconvene at 1:15 in the next room over, which is called Babbage. All right, go get some lunch. And I will see y'all in an hour.